So a few years, actually, I think it was last year. There, after the challenge exam was over, a student said that she had a graph on her test that looked like a heartbeat. And I was just like, I don't know what that is. And then, because it wasn't in our old book, so this book actually has the graphs that look like heartbeats. And so we're going to learn it. We aren't going to draw any of these graphs. All we're going to do is match them. And so if you had never seen this before, it would be really hard to get that question right on the test. But now, hopefully, when you see the graph that looks like a heartbeat, you're going to remember the stuff. And we'll review it before the actual test. But going back to just graphing a regular sine graph or cosine graph, this A, is that going to be an amplitude or is that going to be a midline? The A. A is the amplitude. And D is the midline. Now, what's going to be different about today's graphs is the amplitude or the midline are actually going to be functions. So the middle of the graph could be a slanted line, or the middle of the graph could be a parabola. So it's going to be very, very different looking. Or the amplitude is going to be found by a parabola or a different line. So it's kind of cool. So if you have a function in this form, and this could be sine or cosine, it doesn't matter, they work the same way, where a function is added to it, where it normally was like +2 or +5, it's plus a whole nother function. It's going to oscillate above and below the average given by that function. And this is what oscillate means. It's just doing a little up and down over a midline that's a line, right? And then if the midline is exponential, like 2 to the x or e to the x or something like that, that's going to have a midline that looks like an exponential growth. And it's just going to oscillate. And then this one, if it was something like x squared or 2x squared or something like that, the middle of the graph is a parabola and it's just oscillating up and down. It's kind of cool. All right, then instead of having it added at the end, you have it multiplied by your sine or multiplied by your cosine. It's going to oscillate above and below with the amplitude given by that function. So for example, that function is a line, like a slanted line. You'll have that line, and then you'll have the reflection of that line, and then it's just oscillating in between those two. If it's exponential growth, you'll have an exponential growth line, the reflection of it, and then it's oscillating in between. And then finally, quadratic, you'll have a parabola and then the reflection, and it's going to oscillate. So the amplitude is changing with however the function is. All right, so let's look at some examples. Okay, so this first one, we have this sine of 5x, so that's our sine part. And to it, we're adding 2 raised to the x. So is that going to have the midline be changed or the amplitude? The midline. So 2 to the x is exponential. So this is an exponential, and it's exponential growth, midline. Okay. So we're looking for a function down there that the middle of the oscillation should be in the shape of exponential growth. So what do y'all think? Number 4. So we can kind of draw it. So on that one, when the midline changes, the amplitude is the same. Like this height to this height, those are all the same as you go through. That's pretty much what happens on midline. Okay, and then for B, we have a cosine graph, which is fine. But to it, we have this added. So is that going to be a midline change or an amplitude change? Midline. And what kind of midline? Linear. So we're looking for a graph. It's oscillating, but the middle is oscillating around the line y equals 1/2 x plus 1, or like the slope of 1/2 and y-intercept of 1.
3.
Yeah, it's going to be 3. Okay. One thing I haven't talked about is this number here, the 5s. That has to do with like the frequency of oscillation. I don't think that's going to matter for what you guys need to know. So we're not really going to do anything. I'm hoping it's fine that we're not, but we're kind of ignoring that part and just focusing on what's multiplied or added to your cosine. Okay, so this time is a multiplication. So that's going to change the amplitude. What kind of graph is that? 1/3 to the x. It's exponential decay. I wrote my decay weird. Decay. And that's going to be the amplitude. So it's going to look more like these, where it's oscillating in between two functions. And so we all have an exponential decay function like this, and then the reflection of it. And it's oscillating in between those. That's going to be 1. Okay. And then finally for D, x times sine of 5x. So it's another amplitude one, so it's going to be linear amplitude. So it's obviously going to be 2, but the line y equals x is just a slanted line, and then this one would be the reflection of it. So that's going to be 2. Okay. So you kind of just have to keep straight in your mind what it looks like for the midline changes and what it looks like for the amplitude changes. All right, so on the last example, we're just going to describe in words what the midline and amplitude should be. All right, so what do you guys think about the midline on A? It is going to be a quadratic. So the midline is going to be the graph of y equals x squared minus 1, which, like he said, is quadratic. A lot of people on their worksheet, there's a couple of quadratics, they're saying that x squared is exponential. That is not true. X squared is quadratic. If it's exponential, your exponent will be x. What about the amplitude? That's nothing weird. It's just 8. And we don't have to write that in words. We can write that in numbers. Okay, this one is kind of tricky. The midline isn't. What's the midline? Is there anything added to it? So what's the midline? 0. How about the amplitude? So we had cosine. So it's going to be whatever the value of the absolute value of the cosine of x is at each particular x. Which is kind of crazy. Do you guys remember what the cosine graph looked like? Yeah, it's like the Texas Longhorn. So it's like this. So it would be that one, and it would be the reflection of that. And then, let me change colors. And then you're going to be, the actual graph is going to be oscillating in between those. It's kind of cool. Or you have to be a math nerd like me to think it's kind of cool. But that's what it looks like. Kind of looks like a candy wrapper. All right. Do you all have any questions on this? Okay, so your assignment is a worksheet where you're just matching. And I haven't posted the answer, so as you finish it, I'll check it and I'll give you a stamp all on the same day.